Hi, I'm Eric Gadby, and I have been an enthusiast for all things nautical and aerospace since the age of 10. I served for 22 years in the U.S. Submarine Force and have been supporting it for the last 15 years since retiring. Join me as I pursue my passion for first-person context for ships, aircraft, and historic sites that have shaped our world, as well as some that are off the beaten path. Welcome to the Heritage Hill Air Park, located on McChord Field on Joint Base Lewis-McChord, just south of Tacoma, Washington, home of the C-141B Tacoma Starlifter. Okay, well, welcome aboard the C-141B Tacoma Starlifter here at Heritage Hill in JBLM, just outside of Tacoma, Washington. This is the pilot seat, standard yoke and rudder pedals. This is the tiller handle. This actually controls the steering for the aircraft while you're on the ground. It translates to the hydraulic cylinder that rotate the nose gear. And I'm going to hand over here to my left, have some controls for interior communications, oxygen regulator. On this side, there are breakers and switches for either, you see here, phase A, phase B, phase C. It's a 400 volt AC three-phase system. And hand it back over here to Bob. So it's actually a very large cockpit. We are sitting physically quite a distance from each other. Because of that, there are two sets of engine throttles here so that each pilot can reach them without having to reach all the way across. Have the standard cockpit instruments, altitude, direction finding, artificial horizon, speed, as well as altitude here. Then we have, this is a weather radar that has in the nose, you have a radar array for it. Okay, then the center cluster, you have the engine instruments. These are actually, each one of these has four indicators. Each one of the engines, 1, 2, 3, and 4. You'll see these move up, down to indicate what it is. So, but you can look at each of the four engines, you know, for pressure ratio, N1, which is the low pressure turbine, and the low pressure compressor and the fan RPM, N2, which is the high pressure compressor and the high pressure turbine, exhaust gas temperature, and then fuel flow. Have the standard landing gear. It physically feels like a wheel. It's molded plastic like a wheel. And then you have indicators for the nose gear and left-right gears, as well as the bogies. Then center console, you have the fire extinguishing for each of the four engines. It's a pull to activate. Now above us, you have the actual dimmer functions for the actual instrumentation here in the cockpit. But also you have the starters for the four engines. You see it has here stop, run, and air start. The engines are actually started using pneumatic air that runs to a pneumatic motor to start the engine. So it's held in the start position until it reaches an appropriate point in it. And then it is placed in run, and that actually gets the engine self-sustaining. And center console is pretty much about communications and radar altimeters and just mostly just radios and things of that nature, IFF. And here we have the actual spoilers that can be moved individually. Have aileron trim, rudder trim, and then the actual, they call it for the horizontal stabilizer for it. And then we have the pitch, the trim, just physical for it here. And then autopilots. And I'm going to take the camera and let Bob tell you about his side of the cockpit.
Well, over here we definitely have some of the same controls, and yep, I can definitely reach this from here, and have a nice little wind visor here. I am not as prepped as the other plane for this, but there's another oxygen regulator to help, like the other video.
Where you plug in your oxygen supply at.
Mm-hmm.
And he's got his set of controls there. Okay, well, I'm sitting here at the flight engineer station on the C-141B. So some things that the flight engineer had in his cognizance. This is fuel tanks and distribution network. There are 4 primary, 1, 2, 3, and 4 tanks, and then you have auxiliary tanks 1, 2, 3, and 4, and then there were 2 left and right extended range tanks. So this allows you to bring on pumps to move the fuel between tanks, or to provide it up to the distribution network to go up to the individual engines 1, 2, 3, 4. And we also had here in the center, the aircraft was capable of aerial refueling, so you could bring in fuel in and then distribute it to the aircraft while in the air. Other major components here, you had the controls for the Auxiliary Power Unit, APU, to bring it up online to provide bleed air as well as electricity to the aircraft, and then the T-handle for the fire retard is off. Have 3 hydraulic systems here, 1, 2, 3. So 1 and 2 are driven by, they're off of the engines, and number 3 is actually an electric pump system, so that's redundant. So you have 2 that are powered by engine power and 1 that is powered specifically by electrical power. In the center here, we have the bleed air and air conditioning management system. Each of the 4 engines and the APU can provide pneumatic air into the system to, 1, start the engines, 2, to provide for anti-icing for the various portions of the aircraft, and to cross-connect to allow for pressurization, not for cross-connect, but to allow for cabin pressurization and for air conditioning. So this controls all of that. The other part of the panel here is each of the 4 engines, 1, 2, 3, and 4, had a 400 hertz AC generator that generated 3-phase power, as well as the APU could provide it whenever you are on the ground. And then just more of the controls for frequency and monitoring. And then we had a DC bus that actually provided power whenever all AC power was lost. So, and then finally, I had monitoring for the engine, similar to up front for the pilot and the co-pilot. We had engine pressure ratio, RPM, N1 RPM, N2 RPM, exhaust gas temperature, and then fuel flow. And then for each of the 4 engines, oil pressure and oil temperature, and with a engine vibration here as well. Okay, that pretty much gives us the look over of the flight engineer station. Okay, so this is the main entry door has a nice set of stairs to come back up in, slides up in and out of the way. But also then immediately here is the crew galley. You notice all of the basic things that you'll need: refrigerator, stove, can opener, hot water maker, and just all of the things that you would need for basic crew sustenance. Okay, continuing on here, and built in to the aircraft is the crew lavatory. And also it provides access here into, this is the avionics bay that obviously we're not going to get into for this one. This is our onboard collection and holding. So to add on for whenever you had more than just the crew on board, they brought in this palletized version of, it's a self-contained galley as well as lavatory. It's very similar to here. And just adds capacity to have larger ovens, larger refrigerators, larger storage for freezers, reefers, hot water, coffee, all of the things that actually would make a group or a bunch of passengers be comfortable. And again, this is just the back side of it, hot water spigot. And we got Sean here from the Air Museum. He's reviewing through some paperwork and has been gracious enough to allow us to come into the aircraft to film, and we appreciate it very much. And you can see, obviously, a very large aircraft. From side to side, allows for maximum usage of it for cargo, for passengers, for any kind of needs you would need. And overhead, to have control cables, distribution for air conditioning, pressurization. And whenever we get here towards the middle of the aircraft, on both of the sides here, have hydraulic system number 1 behind panel. So just a reservoir there, roughly about 5 gallons each, 3,000-pound hydraulic system. Then have hydraulic systems number 2 and number 3. So same thing, roughly about a 5-gallon reservoir that allows for 3 independent hydraulic systems. And above us, there would be the plenums for the pneumatic systems for air conditioning and for fuel and everything to distribute out through the aircraft. And seeing that this is a transport aircraft, these are the seating you would get. These are just exact same as the ones like I flew in a C-130 to get into Iraq the first time. Whenever there's not many people in here and you can lay across, these are actually some of the most comfortable seats you'll ever fly on. And I have Bob turn around here. So this aircraft is configured to be able to be set up for beds, both for litters and for medical evacuation. So repatriation of injured personnel, or in the worst of cases, for repatriation of remains. And we're going to continue on down through the aircraft. Obviously, it's a very cavernous cargo hold. And what I'm putting my hand on up here, this is for the static lines for parachutes. We get up here to the port and starboard rear doors. These actually slide up out of the way, and this is where parachute or parachute jumpers can go out into using static line. And get up here further to the cargo ramp. The ramp that I'm standing on right now actually can pivot down to form flat with the rear cargo hold. That way you can slide containerized cargo in and out, and also whenever they're doing actual parachute drops, that actually you can open up this big clamshell doors, open out and out of the way. this tilts down, and then you can actually put out a drogue chute, and then the rollers allow for it to pop out, and then the cargo goes, and then the parachute deploys. So directly above us in this particular area are things like this does have a black boxes, flight data recorder, flight cockpit voice recorder, as well as the pneumatic system, the pressurization, the valves that actually maintain pressure inside the aircraft are located directly above this. So that would come into the aircraft and then up and then out through that huffer or pneumatic valve. And just controls and communications for it. Okay, welcome to JBLM Heritage Air Park. This is the C-141B, the Tacoma Starlifter. I'm going to walk you through the aircraft here. So it is a high wing aircraft. Since it was needed to operate on remote air strips and everything, they went with the high wing to free up the cargo space, as well as to get the engines up off of the ground to keep it from ingesting debris. Okay. First thing you'll notice is the nose gear here. It's fairly far forward, gives it a good turning radius on a tricycle. Controlled by a tiller handle up in the cockpit. And walk along here, the crew entry door here. This is pops in and then slides up, allows it to be operated, from internal to the aircraft, and has a set of stairs that flips down to allow access without assistance from any kind of a jet bridge. And inputs for the flight control system. You'll see the hump up there. That is for the aerial refueling. I'll get some nice pictures of it later whenever I do the high look-arounds. And angle of attack indicator. Emergency exits. And you'll see that the wing is very high up off of the ground. And you'll see from the interior videos that it allows for a very large volume inside the aircraft for storage. Okay, the aircraft was equipped with an auxiliary power unit, or APU. It's located in this portion of the port landing gear. I'm going to take you inside and let you see the plumbing for at least part of it. So that's the duct for the exhaust coming out. The inlet was directly, 90 degrees perpendicular to this up on top of the fairing. So up inside the port main wheel well, you can see it's a very spacious area. The gear itself is designed to translate. You have a cylinder there that pushes this and pushes it forward and rotates it up. So these wheels would come forward into the area that I am in now. So that's how it works. And then for ground operations, it has a door here that pops open to allow the master cylinder to open. It is a double bogie, 4 wheels, pretty substantial brakes on. The aircraft needing to be able to stop in a, I guess you'd say, a large, heavy cargo in austere conditions. And the hydraulic cylinder that operates the mechanism for it. And you can see the ground clearance on the aircraft here as I'm looking around. I'll step back outside here. And I'd mentioned the That is the inlet for the APU, the small turbine. Gives electrical power, pneumatic air, and provides unsupported operations. Okay, I'm gonna walk around here and take a look at the main engines. It was powered by 4 TF33 low bypass turbofan engines. It was a 7-stage low pressure compressor driven by the 3-stage low pressure turbine and a 7-stage high pressure turbine or high pressure compressor driven by the high pressure turbine. So 14 stages on the compressor, 7 low, 7 high, and then a 1-stage high pressure and 3-stage low pressure turbine. It's configured to have thrust reversers. That is these clamshells you see right here. They rotate 90 degrees to form a bucket to shift the thrust from going, pushing the aircraft forward to direct it to be blasting to the forward to provide for stopping power. And you can see just how large these things are. And underside of the main wing here, inboard flaps. And it's number 1 engine here. And aim high. There goes C-17. I'm going to take you out here to the port wingtip and look back. It gives a good look at how far out on the wingtip you actually get and how the difference in height from the wing root. Now the wing was essentially an entirety of a fuel tank. Have the ailerons on here, then the outboard flaps. I'll see if I can't find a nice picture here that shows these extended down to insert. Okay, the aft access door here, this actually opens similar to the forward one. It opens in and then slides up. This is actually an egress point for paratroopers, and whenever they do that, they actually have a blast shield that can rotate out to the leading edge here to provide some relief from the instant blast whenever you step out. Gonna look here at the rear cargo ramp now. This is hydraulically operated and can come down to allow for access to put to the main deck. It is level with it. So large cargo loading in and out. The rear cargo door here, these 2 clamshell ones, these open outwards and can stay in the slipstream of the aircraft to allow for this to actually be opened and to do parachute dropped cargo. I'll see if I can't find a nice video or graphic to show in of that happening. And get back over here to the port side now. Okay, I'm going to zoom in up on the horizontal stabilizer there at the top of the T-tail. You can see that nice silver section. That whole assembly tilts up and down. That is allows to trim the aircraft for different weights and as they burn up through fuel or shifting loads. There's a jack screw just inside that actually screws it up and down to change the angle of attack or lift on the horizontal stabilizer. And then you have the and we got single piece rudder here attached to the vertical stabilizer. It has redundant power to it and hydraulic, as well as dampers and different speed regimes. It allows for different authority on it. And continuing along here along the starboard side, now look back here at the tail. One thing you do notice is that there is a bulge at the rear. That's to accommodate the actual loading doors on the back and to provide for all of the mechanisms and everything that need to operate it. Okay, and for fuel loading, you connect here. And just continuing out here underneath the starboard wing, engines 3 and 4. You can see it's just a really, really large surface. It's a very large wing, gives a lot of lift. And we'll walk around engine 4 here. And work our way back around the front of the aircraft. Thanks for watching and for sticking around to the end. I truly appreciate all of your views, likes, comments, and especially for those who are returning subscribers to the channel. I especially like hearing from those who have first-hand experience with these aircraft, so keep the comments coming. I'd like to extend a special thanks to Sean Zawada and all of the staff at the McChord Air Museum for their work in restoring and keeping these amazing pieces of history available for future generations to enjoy.